Good day everyone. Today we will be discussing John Dalton's atomic theory. But first, let us know who is John Dalton.
John Dalton was an English chemist, physicist, and meteorologist. He is best known for introducing atomic theory into chemistry. When we go to the internet to search when was Dalton's birthday, we will see an info saying that his birthday is on September 5 or 6. It is confusing, right? Because even Google doesn't know when was Dalton's birthday. But if we do a research, Dalton is born on September 6, 1766. He was born at Eaglefield, Cumberland. John Dalton was an intelligent child who took an interest in the world around him and tried to learn as much as he could at everything. In 1794, he wrote his first scientific paper, which he called Extraordinary Facts Relating to the Vision of Colors. This was the first ever paper to discuss color blindness. Dalton had realized the condition was hereditary because he and other members of his family had it. He was the first scientist to take academic interest in the subject of color blindness. His interest stemmed from he and his brother being colorblind. John Dalton postulated that shortage in the color perception was caused by discoloration of the liquid medium of the eyeball called aqueous humor. He conducted the first ever research into color blindness, a subject which subsequently became known as Daltonism.
Now that we know who John Dalton is, let us now proceed to his atomic theory. What is John Dalton's atomic theory? Dalton's atomic theory is a scientific concept which states that all matters are composed of tiny, invisible, and discrete particles called atoms. Dalton hypothesized that the law of conservation of mass and the law of definite proportions could be explained using the idea of atoms. He proposed that all matter is made of tiny invisible particles called atoms, which he imagined as solid, massy, hard, impenetrable, and movable particles. The atomic theory was developed by John Dalton after he made the observation that chemical substances combine and break down into other substances by weight, which suggested that such chemical substances are made of smaller particles with a particular weight. In 1803, Dalton discovered that oxygen combined with either one or two volumes of nitric oxide in closed vessel over water, and this pioneering observation of integral multiple proportions provided important experimental evidence for his incipient atomic ideas. Dalton's atomic theory is based on two other important chemical laws of the time: the law of the conservation of mass by Antoine Lavoisier, and the law of definite proportions by Joseph Proust. The law of conservation of mass states that matter cannot be created or destroyed. The law of definite proportions states that a given chemical compound always contains the same elements in the exact same proportions by mass. Dalton, in the atomic theory, also introduced the word atom as the most fundamental particle of a chemical substance. The most essential concept of Dalton's atomic theory is the suggestion of all matters are composed of atoms, but there are other different concepts in the form of postulates of the theory that will be discussed by the next reporter.
Let's understand the postulates given by him in his atomic theory. Composition of matter. Consider an element, for example, gold. See what it's made of? As you can see, it is made of particles of the same type. Whereas a compound like water is made of particles of two different types. A closer look at the mixture of iron and sulfur enables us to see that it is made of very tiny particles of iron and sulfur. Dalton called these tiny particles that matter is made of as atoms. All forms of matter, whether an element, a compound, or a mixture, is made up of very tiny particles called atoms. Indivisibility of atoms. Consider a piece of the metal gold. When you try breaking a piece of the metal gold into smaller pieces, at some point it becomes impossible to break it any further. Dalton called the smallest particle of matter an atom, and he further stated that the atom is indivisible. Atoms of similar elements. Consider a pure gold coin and silver coin. Pure gold coin is made up of gold atoms only.
Good day, sir. I am Neil Harben Robles, and I will be talking about merits of Dalton's atomic theory. Merits of Dalton atomic theory. Although there are many drawbacks of Dalton's atomic theory, it played a crucial role in the development of modern atomic theory. Dalton's atomic theory was able to explain many of unanswered questions in the 19th century. And John Dalton is considered as the father of modern atom theory. Here are the merits of Dalton's atomic theory. Ability to explain the law of conservation of mass by using Dalton atomic theory. So, the law of conservation of mass says that the matter is not created or destroyed in a closed system. That means, if we have a chemical reaction, the amount of each element must be the same in the starting materials and the products. Also, we can explain the law of chemical combination with all possibilities based on theory. One of the most important merits of Dalton's atomic theory is the fact that theory does not have violated several fundamental laws of chemical combination, such as the law of definite proportions, the law of multiple proportions, and the law of conservation of mass. Another important merit of Dalton's atomic theory is that it provides a basis for scientists to differentiate between elements and compounds. And according to Dalton, elements are composed of only one kind of atom. Compounds are made from two or more kinds of atoms.
A pleasant day to everyone. I am Dan F42 and I will be talking about the limitations of Dalton's atomic theory. The advancement of the composition of matter gradually posed some limitation to Dalton's atomic theory. The first one is it does not account for subatomic particles. Atoms, according to Dalton's atomic theory, are indivisible. This theory was refuted by the discovery of subatomic particles like electrons, protons, and neutrons that can further divide an atom, disproving the idea that they are indivisible. The second one is it does not account for isotopes. In accordance with Dalton, all aspects of an atom belonging to the same element are similar. However, the masses and the densities of atoms in some elements vary. For instance, the isotopes of chlorine have masses of 35 and 37. The next one is it does not account for isobars. Dalton also asserted that every aspect of an atom differs depending on an element. This has been shown to be inaccurate in certain instances, like the atomic masses of calcium and argon are 40 AMU or atomic mass unit. Then the fourth one is elements need not combine in simple whole number ratios to form compounds. Dalton asserts that compounds are created when atoms from various elements combine in simple whole number ratio. This is not observed in complex organic compounds like sugar. The last one is that theory does not account for allotropes. Dalton's theory is also unable to explain the presence of allotropes and does not account for variations in the characteristic of materials such as diamonds, graphite, and charcoal.